Okay, so this is section 2.6, some more practice problems. We're going to do some practice problems with the limit definition of the derivative. So this is the limit definition of the derivative. We were using the four-step process in the previous video. So if we were to follow that, in step 1, we would compute f of x plus h. Now in this case, f of x is a constant function, 7. If this had been 7x, then for f of x plus h, we would have plugged in x plus h for x, but there isn't one. This function is 7 no matter what you plug in for x. So it's just 7. In step 2, we do this numerator difference part of it. So it's f of x plus h minus f of x, which in this case is 7 minus 7, which is 0. In step 3, we do the difference quotient, which is f of x plus h minus f of x all over h, which in this case is 0 over h, which is 0. So finally, the last step, step 4, to find the derivative f of prime of x, we take the limit as h goes to 0 of f of x plus h minus f of x all over h, which happens to be 0, because we're plugging in 0 over h, which is just 0. And thinking about it, this shouldn't be a surprise, because the graph of that function, this is y equals 7, is just a horizontal line. And this is 7. So the slope of a horizontal line, you may recall, is just 0. If you were to keep that in mind, the next problem, the slope, since it's a linear equation, it's mx plus b, m is negative 3. But let's try to find the derivative by doing all the steps and see if it actually matches. Because remember that we won't be just sticking with lines, we'll be looking at other equations of quadratics and other powers, so we won't be able to do that then. So to follow the steps, f of x plus h, it's 7 minus 3 quantity x plus h. Again, order of operations, you can't change this part as 7 minus 3 is 4, because multiplication comes first before subtraction. So instead, this is what we will do, distribute the minus 3 through. In step 2, do the top portion of that difference quotient. It's f of x plus h minus the f of x. So it's this 7 minus 3x minus 3h minus, in parentheses, or distribute the negative, you get that. Clean that up. 7 and minus 7 cancel, that cancels, I get negative 3h. In the next step, you take the top and form the difference quotient. Essentially you divide that by h. So the h's cancel, you get a negative 3. In the final step, where you find f prime, you're taking the limit as h goes to 0 of whatever you got here, but this is a constant, so the derivative is just negative 3, which is what we had guessed, because this is a line, the slope is negative 3. But now, we no longer have a linear function, so let's do the steps, see what happens. F of x plus h, step 1, it's x squared minus 2. In this case, x squared is x plus h quantity squared. And in the previous video, I had shown you how we did the FOIL, write it out as x plus h. So we'll just skip that step and just do it every time. It's x squared plus 2xh, or hx, plus h squared minus 2. Step 2 is the top portion of the difference quotient is this, copy it down, minus f of x, which the sign, negative sign, distributes. Things clear out, and we have 2hx plus h squared. Step 3, we form the difference quotient. We have 2xh plus h squared divided by h. That's in the formula, the h. We can leave it here, or we can anticipate that in the next step we're going to find the limit as h goes to 0, and I will make the 0 on top and 0 on bottom. So why not just factor out the common h right now and save us from the bother later. So here the h's cancel, which gets us nice and ready to find the limit. The derivative f prime of x is the limit as h goes to 0 of the difference quotient, which is now 2x plus h. Plug in 0 where h is, 2x plus 0, and that's the derivative, 2x. Alright, next problem. This one is also second degree, like the previous one was. This one was also second degree. And notice that the derivative ended up with x to the first degree. Over here, x was the first degree, the derivative lost the x totally. And here, the function was a constant, the derivative was 0. So we'll start looking at patterns. When we hit chapter 3, we'll be speeding up all this into just one step. Okay, the 4-step process. Step 1, f of x plus h is it's x squared minus 3x. That's the function. So I'm leaving placeholders for that and plug in x plus h into those placeholders. FOIL this out, x squared plus 2hx plus h squared. Distribute the negative and you get that. In step 2, we take the numerator of that difference quotient. So you copy all this down. It's f of x plus h minus f of x. Distribute the negative. Some terms cancel out, so you're just left with 2hx plus h squared minus 3h. And in step 3, you form the difference quotient. So this is all of this divided by h. And now, after having done a few of these questions, we'll take out the h right now in preparation for the cancellation. Okay, so this is what we get left when we take out an h. Cancel the h's. In the last step, simply take the limit to find the derivative. So f prime of x is the limit as h goes to 0 of 2x plus h minus 3. Plug in 0 where h is, and you just get 2x minus 3. So notice how the 2x came from the x squared term. And this was a linear term. It's like mx. Its slope, its derivative is minus 3. So keep this in mind as we do section 3.1 in future videos. Now the last example is a strange one. This is not a quadratic or linear. It's a square root function. So when I go to do step 1 and write out f of x plus h, I end up with the square root of the input, which is x plus h, and I can't really go any further with this. So I'll move on to step 2, which is f of x plus h minus f of x, which is this minus the function root x. Once again, I can't go any further with this, so we'll move on. Step 3, we form the difference quotient. So we need to divide all this by h. So the square root of x plus h minus the square root of x all over h. Well, we can't really do anything with that either, but start thinking about what happens when you go to find the derivative. You take the limit as h goes to 0. You plug in 0 there for h, and there you get the 0 over 0 form. So we need to do some kind of algebra to expose the bad factors that are causing this. And since we have square roots, we're going to have to use conjugates. So it's this, and change the sign in the middle, do plus root x, do it to the top, and do it to the bottom. Now remember, the rule is to look at the conjugates only. Don't distribute this. Leave this h exposed. This h is going to 0. It's causing all kinds of trouble. We want to cancel it out. So do not multiply that in. Instead, when you multiply the top, you get x plus h, because the square root of that times itself. The square root goes away. And when you do the outer and the inner, they cancel out, because these are conjugates. So you do the last. Negative times positive is negative. Root x times root x is x. And like I said earlier, leave the h out. Do not distribute it. This x and minus x cancel out. And now you see the h over h. That cancels, leaves you with a 1 divided by square root of x plus 0 plus the square root of x. 0, because I'm computing the limit as h goes to 0. So this is root x plus root x. When you add them, you just get 2 root x. So that was kind of laborious, but we will soon see some shortcuts. But in the meantime, this is kind of interesting how the derivative of the square root of x turns out to be 1 over 2 times the square root of x. It's not something you usually expect. So I'm going to pause this video, and we will do one more video for section 2.6, where we wrap up the entire homework for 2.6.